In some carbon chains, when there are two functional groups which can react with one another, cyclic molecules are formed by the reaction between them. The reaction between which of the following would give rise to the formation of such cyclic molecule? Yeah, see what happens. Here, this turned into this membrane. We have this phenol will not react with PCl5, but the carboxylic acid will react and give us Cl. When these two react, this becomes Cl. Then, because of these two are very close, the Cl will go with this hydrogen, forming HCl. So the rest will be joined and form a cyclic compound. Methanol, we have that carbon, oxygen, here CH2, like this. Here THCH2. Though this is a cyclic compound. Itself a cyclic compound like this. In this case also we can, because 1, 2, 3, 4, yeah, this can be cycle or turn into cyclic compound. When we add PCC, this becomes HC, CH2, 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 NH2. This H2 will react with the oxygen here, forming new cyclic compound like this. Carbon. We have 1, 2, 3, 4 another. CH2, 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 CH2. Like this. This is a cyclic compound. Even here, when we add lithium aluminum hydride, this becomes OH, then OH will not react with NH2. OH will not react with NH2, therefore it cannot use to that cyclic compound. Here NaNH2, this will be replaced by Na, that Na may go with this Br. That D can be. If this can, when 1, 2, 3, 4 carbon available, this also can, because of the presence of 1, 2, 3, 4, the same number of carbon, then this will give us whenever CH now becomes CNA. This Na can react with this Br, giving same kind of a cyclic compound. This can give a cyclic compound if B can. If B can give a cyclic compound, then D can give another cyclic compound like this. But we have this sodium. Sodium will go with this Br. We can see CH2. Now we have 1, 2, 3, 4, 5 carbon. 1, 2, 3, 4. I have already. Another CH2 will give this kind of a product. This is also possible. So your answer must be the A, B, and D. The fifth one. If B can, D can. But C cannot be because of the reduction of that first. Consider the electrochemical cell constructed by the electrode of metal X and Y under standard condition, and the standard electrode potentials are given. Y is negative, X is positive. That means Y is more reactive than X. Then if you construct a cell, Y is the anode and the X is the cathode. Which of the following statement true? In this cell, electron falls from simple arrangement. Here Y is the oxidizing one. This is the X. Metal X, say X2 plus ion. Here Y2 plus ion, say this is Y. Then we connect that using a solder bridge. Then you may connect that to a bulb or any other. Like this. Then what happens? This is the one which is oxidizing. It gives us Y2 plus ions to the medium. In this case, what happens? X2 minus will be deposited on that. Otherwise, electron will flow from Y to A through the external circuit. In this cell, electron flow from X to Y, that is wrong. Always anode to cathode through the external circuit. Oxidation takes place at Y, that is correct. Namely, Y is the one which is oxidizing. Y dissolve and give us the Y2 plus ions to the medium. So the second X electrode is the cathode, that is correct. Y is oxidizing, then anode, X is reducing, so cathode. In the cell, this is the cell potential. E cell equals E cathode minus E anode. So the E cathode is equal to 2.57 minus 0.14. So the cell potential is 2.71 volt. So answer is B and C2. Consider reaction A, B, C, D. This is not reversible reaction, right? This is not a reversible. For some concentrations of AB, the initial rate of the reaction is R. When the concentration of A is doubled, keeping the B concentration constant, the rate of become 2R. While B is doubled, 4R. It's the following are true. Rate can be written as K times A concentration to the power simple A and B to the power simple B. It says for some concentration rate is R. R equals K, A concentration, B concentration. Then what they have done? They have doubled. A is doubled keeping B constant. A is doubled. If the R is R1, R1 is equal to K to A. 2A to the power A. B is same as B concentration. Next, though I can divide these two equations, then BB will cancel, A will remain. R1 is equal to A 1 by 2 A. In this case, it says that the R1 is, the rate is 2R. Therefore, A is 2. In the next reaction, what they have done, by keeping A constant, they have increased the, no, A constant, the rate become 4R. When B is doubled. When B is doubled, say R2 equal 4R. Temperature is 4 times as that. So divide K times A concentration to the power A and B concentration to the power B. But in this case, it says that the B doubled means 2B. This is my third equation. Again, what I do is I divide 1 over 3. When we divide them, A will cancel, B become 1 over 2 to the power B. This R2 is given as 4R. R will cancel. එතකොට අපිට එනවා මොකද්ද 1 over 4 equal half to the power B equals half to the power square. So B equals 2. Here it is 1. Here 1, A equals 1, B equals 2. What they ask? The first order reaction with respect to B, that is formed. It is second order with respect to B and first order with respect to A. Right? Road A is wrong. B, the rate of consumption of B is greater than the rate of consumption of A. No, it is same. Why? Stoichiometric numbers are same, means the rates are same. Though the power is 2, power doesn't mean that it race is not equal. Rates are equal. The thing is, if you change the concentration in the A or B, the rate of the entire system will change. Total, the consumption of B is same as the A. Why? Maybe 1 mole of A react with 1 mole of B. So at the same time, it has to be reacted. A mole react or B mole react. So the rates are equal. It cannot be a one-step reaction. Never say that. Order එක වැඩි වෙන්න reaction එක complicate complex වෙනවා. So it cannot be a one-step reaction. Normally remember that when the order increase, the reaction become much complex and complex. Right? So first step in the behavior. Its overall load is 3. Yes. Overall load is 3. That's correct. C and D are correct. That is the answer. Which of the following statement is true about the nitration of benzene and its derivatives? Nitration of benzene and its derivatives. It is an electrophilic addition reaction. Normally, all the reactions of benzene are electrophilic substitution, not addition. Why? Instead of hydrogen, NO2 will be substituted. So it is electrophilic substitution. Toluene undergo nitration faster than benzene. That is correct. Why? Benzene connected to CH3, that CH3 will donate electron towards the ring and so it will be much activated. But if the ring is activated by something else, then it is called fast. Then it is fast reaction. The intermediate carbocation formed in the reactions are stabilized by the delocalization of the positive charge. Yes. Benzene ke NO2 react lahama metal hydrogen so we cannot put it. So you may have this kind of bond, so it is plus. And it will be delocalized because of these resonance structures. Like this. So you can write down it is stabilized by that. Then the chlorobenzene undergo nitration faster than benzene. No. When chlorine, bromine, no iodine attack to benzene ring, we call deactivate the benzene ring because of the high electronegativity of this chlorine. It attracts the electron cloud of this benzene ring towards the chlorine atom and deactivates the ring. But still it is orthopara director, but it does not increase the rate of the reaction. It decreases because of that. So this is wrong. So the B and C are correct. Answer is second one. And the finally 38. Which of the following statements are true about the chemistry of the compound containing nitrogen? Nitrogen containing compounds. Ammonia acts as weak base as well as an acid. Yes, it's true. Nitrogen containing compound ammonia. Ammonia is an acid and also base. I have given the examples also at the very beginning. We wrote some reactions here. An acid and a base are formed by the hydrolysis of NCl. NCl3 react with water. NCl3 react with water. Giving ammonia plus HOCl. Ammonia base. This is acid. N2O can be prepared by heat in mixture of ammonium chloride and sodium nitrate. Again, NH4NO3. If you heat this, you will get N2O plus water. That is correct. In exam, if you find 3 answers are correct, first 3 are correct, then we don't check the other one. If it is pretty sure, my answer is 5. Now the answer is 5. Let's see the other one also. HNO2 and HNO3 are two very strong oxo acids formed by nitrogen. No. This is very strong, but this is not a strong acid, it's a weak acid. Therefore, answer is anyway 5.